All right. Hello, everybody. I'm here to talk about my experiences last weekend with ISTS, some of the CTF challenges, one in particular, and my experience using Scratch with them. I'd like to give a quick shout out to the Wireless Interest Group and Braden over here for their assistance as well as their great deal of knowledge that they bestow upon us. Now, to get started, let's talk a bit about who I am. My name is Camden Robertson. In my free time, I like to snowboard and do Scratch. That's me being Walter White for Halloween up there. I thought it was pretty good. And I'm a big Linux fan when it comes to blue team competitions. I do like doing devious activities. I think during my purple team debut at ISTS, I had quite a blast, so that was great. So I know a lot of you guys are going to be very hesitant when it comes to using Scratch, so I just like to address your concerns by saying these are some valid concerns. You probably shouldn't use Scratch because it's literally GUI-based block coding. It's a little bit amateur. Some might think it's for little kids. It's got a lack of compatibility with file systems and APIs. That sort of limits where you can use it. It's a big limitation, but there kind of are exceptions to this rule very rarely. You can actually run your own Scratch servers, but it's kind of not a common thing. It's also slow because it's got that excessive abstraction. Everything is very verbose, very literal. And it is a bit too beautiful for most people to appreciate, so I do understand why there might be some hesitation. So let's move on. Let's talk about why you should use Scratch. If you really like extremely readable code, very easy to understand even without annotations, if we look in the bottom left here, we can actually see just how easy it is to read. Instantly, by just looking at all these blocks, we can tell exactly what they do. You know, when the green flag is clicked, you might want to wait a second. You got some if-then statements. It's all just so perfect and legible. You don't need syntax knowledge. You're not going to be looking at documentation all the time. No IDE required. Scratch is your IDE. And it's just so beautiful. I love it. So let's take a look at the CTF question in question. This isn't a real screenshot of it, but it's a recreation on my private server. And it was called IQ test. I believe Braden wrote this one. It was quite excellent. Some real heat going on. And it's got some cool stuff. So we've got this IQ test text document. It's got some comma-separated values. And the description says, take this IQ test to check if you've really got the smarts up there. Make sure that gray matter is working and the signals are all firing. So we can examine this question a bit more in detail. We can look at our clues, right? Now, if you're not reading all that on the right, that's basically just me using one of the premier CTF tools of the century, ChatGPT. And yeah, I was thinking about, we've got this CSV file here, right? And it's got an integer from basically 0 to around 345, basically 360. And we've got a float from 0 to 1. And these can be thought of as maybe polar coordinates or maybe a strength and a phase, sorry. It's like an angle and a strength. And that is sort of like polar coordinates, if any of you guys remember that math. So using ChatGPT, as well as my previous knowledge from Wireless Interest Group, we're able to deduce that this could be something like quadrature amplitude modulation. It's a big word. I'll go over it in a later slide. Don't worry. We can also look at this question text and pick out some clues, some analysis. Some important words are signals, like duh. I don't know, Braden would be the type of guy to make a CTF challenge about signals. We also got IQ graphing. Sometimes, the sine and cosine of different aspects of a wireless signal will be graphed as I and Q on the X and Y axes for signal purposes. We've also got gray, that gray matter. What could this mean? We were thinking maybe some gray coding for QAM. I'll go into that too, don't worry. So now that we've identified our clues, we can talk about what the heck this is. It's a big, scary word. Quadrature amplitude modulation. So let's start from the top. You've got Wi-Fi. It's some high-energy radio waves, microwaves, micro wiggles, if you will. And they've got a phase and an amplitude. This is basically how strong it is and how fast it is. And we can graph these two data points in polar to place them on a grid, as this GIF is doing right here. Is it GIF or GIF? Yeah, but basically, on this left side over here, we've got a sort of QAM diagram. We can see we've got 4 QAM, which is a small box in the middle, 16 QAM, 32, and it gets bigger and bigger. And these are how we're going to map basically our strength and our angle values to specific binary values. So if we look at our resources, we've got 3 main things we're going to use. We're going to use Scratch in order to basically turn these strength and phase values into that binary code. We're going to use CyberChef to convert that binary code into plain text so we can read our flag. We're going to use Braden because he can give us a lot of useful hints if he's paid enough. I know in the ISTS store, I spent like a hilarious amount near the end on hints for the CTF. It was good. So now we can plot the points in Scratch. I made an educated guess of 16 QAM. If you look back at this little table graph here, you can see it's a 4x4 grid. Basically, each value on there is going to be 4 bits. So given that guess, as well as noticing that in the CSV file, it was basically only 3 different amplitudes. It was hinting at a low range of possible values. And yeah, so if we move forward with that, we would convert it to binary using something called a constellation diagram. This is also a little bit scary, but if we look here, it's essentially mapping each sort of quadrant, not quadrant, but 16th of that grid to a different binary value. So wherever each polar vector ends up, we can say, okay, this is the binary sort of value that goes to it. And so we also brought in our gray coding knowledge. And what gray coding is in this sort of constellation scheme is what this little graph is called. It means every sort of adjacent block is only 1 bit different. And this is done to sort of minimize errors if there's small changes, I believe. Is that right, Braden? Gray coding? Yeah. Yeah. So we could see, like, for example, if the data was meant to be represented in this bottom right corner, and, you know, something funny happened and it accidentally did this one here, it's only 1 bit off, which isn't as bad as it being like 4 bits off. I think is the main sort of thought process there. So yeah, we can graph it and we can apply these binary values onto our Scratch plot and then use some mathematics to just sort of parse that all up. So let's explore. Let's check the demo. I've got it pulled up right here. Oh, hella devious. All right, so we can start our project here. There's a lot of cool stuff on the screen right now. Realistically, that doesn't need to be up, but I think it's kind of cool looking. And it helps to understand the process a little bit. So what we're going to do is we're going to open up our file right here, copy the text that was included in the challenge, and we are going to paste it in the bottom here. So now what it does is it adds to all these sort of lists with all the angles and let's non-full screen it again. All the angles and the radius. Adds those to 2 different lists, parallel lists if you may, and that's just parsing the data. So now we can use that data and we can graph. So I've made it so that every time I press space, it shows the next sort of vector, and it's plotting them, if you notice, in all these different little squares, 16ths, as I said before. I'm not sure what the right word for that would be. Yeah, but we're plotting it. We can see the binary. It's being collected up there at the top. So we're just going to keep on going. I think there's like around 43 or so. And once we're all set with that, it pastes it into here, this selectable binary output field. And after that, we can just go to CyberChef. Whoops. CyberChef. Ba-boom. One of my favorite tools. And once we're in here, we can paste this binary we copied, take the from binary decoding option, and boom, we got the flag right there. It's that simple. So if we're walking through the code here, I can just give a brief overview. It's all in one function pretty much, just because it's so readable, you don't even need to worry about it really. And yeah, so at the start here, all it does is ask for your data, and then this loop right here is parsing it. It's turning all this text and all the spaces and stuff, concatenating them and filling up these lists here. And then right here, we're drawing the list using sort of a turtle almost. And this section here, it's got this big scary equation that uses ceiling and stuff like that, but all that does is I used to have this before, like this huge nested if loop. It's quite disgusting, even for Scratch. So I changed it to this cool looking for function. And what that does is it maps basically each grid up here into the different QAM constellation codes. And the way this is made, you can actually change these constellation codes if you have a different sort of, I guess, key you want to use. And that's about it. So thank you all for watching. Do we have any questions? Yeah. What? Well, yeah, so Anthony's asking, how did you know how to do this in Scratch? How are you so wise? Um, yeah, and for that, I say Scratch, to me, it's quite beautiful. It's I've got a pretty good grasp on, I guess, procedural programming, things like that. But some place where I really struggle sometimes is just knowing specific syntax. And I felt that using these blocks might just be faster, especially in sort of the time crunch situation we had during ISTS. So just knowing how everything works already makes it quite easy. And it's less complicated than you think. I'm essentially graphing in polar right here by just moving sprites. Scratch is not object-oriented, it's sprite-oriented. So I would love to go into this in more detail if you're interested, but I don't want to make some people fall asleep. So unless we got any other questions, that's probably it. Yeah. How can we use this offensively? Scratch C2. That would be pretty crazy. Like I said, the file input output and I guess like the external applications of Scratch are a little bit limited, but it's something I could look into. It could be fun. Yeah. Anything else? Exactly. The best programmers can program in anything. Thank you, Brad. All right. I believe that'll be it.